Hey, what's up everybody? So today we have a C++ video. I've never seen actually this on YouTube or anywhere because I've been looking around for it and no one's implemented a linked list like I did. So I made a linked list where it's kind of like a high level linked list where it works with like a string, works with an integer, it works with chars. You know, it's like a high level linked list and I haven't seen anybody do it. So this is very special because I think this is pretty cool. I just started learning C++ like, 20 days ago, like start of February. So without further ado, let's do it. This is a linked list. Let's include IO stream since we're going to be printing out the linked list. Let's make our main function. And then let's just give that spacing. And then we're going to be using a namespace because we like to be neat here, so let's say namespace. And the class that I'm teaching, I'm a TA now, guys, so I'm teaching data structured algorithms. That's why I'm saying DSA. So DSA namespace, and we're gonna make a node class, and we're gonna make linked list class. And by the way, guys, I'm sorry if I'm whispering. It's because it's very late here. It's 4:18 in the morning. So we're gonna templatize our classes, and the reason why we're templatizing our classes is because this allows it to accept many data types: integers, strings, chars, whatever. The thing is, we'll have to specify what type we're using in the main function, so we'll watch out for that later. Okay, so by default, a class has access modifiers to be private. So by default, it's private. We want to make it public just because, we're working with like a local project. Security is not an issue. So a node usually has data, and this data could be either, integer, string, whatever. So we're going to use the keyword t here that we just made up here. This can be whatever you want it to be, by the way, but most people use t. We're going to say data, and then we want a next, a pointer to a next node. So we're going to say node t next. And notice I have to specify what type of variable, what type of data type we're using. And since we don't know yet, since we're in the class, we're going to specify it as t. Okay, so that's our properties. So let's go ahead and write properties. Maybe this should go underneath. Okay. Now let's make our constructor. Our constructor is going to have the same name as our class, so node. There we go. So this is a default constructor, it just takes no parameters. However, we can still make it say data is going to be null, and next is going to be null. There we go. So this is like a default constructor. The property is going to be just empty. Now we want to have a constructor that actually has something inside of it, the parameters. So we're going to say t data, and I like to make my parameters like super small, so like x. I'm going to say data x, and then next is going to be null. Alright, perfect, guys. So if you guys don't know about these one-liner constructors, really fun, really cool to do. Alright, now we're in new functions. So let's make getters and setters. So we can say void set data. This is going to take data, and this is just going to say this data equal to data. Okay, now let's get the data, and this is going to return t get data, and this is just going to return this data. Okay, and don't forget your semicolons, super important. We're going to do the same thing with next, so let's just copy and paste this logic. Okay, now we're gonna say get next. We're gonna say oh, I'm sorry, this is set next node t next. This actually needs to be a pointer, guys. The reason why it needs to be a pointer is because we're gonna access this this node's other next, right? Because a linked list works like you're making all these other nodes next pointer point to a next node, and without that pointer, we won't have the actual node. We'll have a copy of the node, and then the linked list just falls apart. If that made sense, it probably is not supposed to make sense. References and all that stuff is really confusing. But yeah, we just need that. So, all right. We need to actually have a pointer here as well, and then this has to be this. Awesome. All right. This next. Okay. All right. So I think that's it for our node function, our node class. Let's go ahead and make our linked list class. So again, we have to. It's giving me a squiggly. Yeah, semicolon. Okay. Let's go ahead and make another template. Since we're gonna need it, since we're gonna make nodes inside of this linked list, we're gonna need another template, and you'll see what I'm talking about in a second. So again, we need to make public access modifier. We'll say properties, and then let me just scroll down so you guys can see a little better. In a linked list, we have a head, a tail, and a size. So let's work with that. So we're gonna say node t, right? We have to specify a type, and since we don't know what type it's gonna be, we gotta just do it this way. Don't forget your semicolons, guys. There we go. Node t is equal to this is gonna be head. Go to t. It's gonna be tail, and then finally we're gonna have an int size. Right now we can work on our constructors. Now our constructors are gonna have the same name as our class, and then this this default one is gonna have everything to null. So it's just gonna say head null, tail null, size 0. Perfect. Okay, so that's one constructor down. I think that's the only constructor we need, actually. So what else do we need? Now we need to do the functions. We're gonna need to add to the list. That's a really simple one. Well, it's not really simple. It's probably the most challenging one. But obviously, like to someone using a linked list, you gotta be able to add to it. So a very essential function here. So we have two cases when we add to the list. List is empty, and then list is not empty. If the list is empty, size is going to be equal to 0. So we're going to say if size is equal to 0, we're going to make a new node and put it inside of the list. Okay, so we can either make the add to list function accept a new node, or we can make accept data, and then we'll make a new node inside of the function. That's what we're going to do. So we're going to say t data, and we're going to say node t, and then we're gonna actually, since we're making nodes on the fly, we're gonna make dynamic nodes. We're gonna have to use the new keyword. So we're gonna have to, the new keyword makes a address of a new node object, and we're gonna need pointers for this. So we're gonna say new node equal to new node. This is very confusing, guys, I understand. And and then we'll use the constructor, and then we'll say data. Okay, so if you guys remember, our node constructor up here accepts the data, and then it's gonna, with that, it's gonna make the data accept whatever we pass it in, and then the next is gonna be null. Alright, so hopefully that makes sense. There we go, we have our new node. So we'll say this dot head is equal to new node. Okay, and then this dot tail is also equal to new node. And then we're gonna say this dot head dot next is equal to tail. The reason why is because head needs to have some type of connection to tail. If it's confusing, honestly, I drew it out myself and I still didn't get it. But after a million tries of doing this, it worked. So I mean, that was the one piece of logic I was missing. So that's something you have to do. Okay, so else, if the list is not empty, something very important, guys, we have to do this dot size plus plus. Okay, alright, so now when the list is not empty, we're gonna have to say this dot tail, and usually when the list is not empty, you're always going to be messing around with the tail. The head is probably, you know, done with, unless you're adding to the front, which is that's not the type of list that we're working with. So yeah, this dot tail dot next is going to be equal to new node. Okay, and then this dot tail is going to be equal to new node. Okay, so the previous tail, right? This is the previous tail. Now the next of the previous tail is going to equal to new node, and then we update tail. So now his tail is finally at the end. Hopefully that makes sense. Yeah, I mean, like, data structures is supposed to be frustrating. Okay, so add to list looks like it's looking good. Let's go ahead and print this out. So let's say print list, and this is going to be a void function. It's a complaint name for, oh yeah, that should be good. Okay, alright, print the list. So we can do this with a while loop pretty easily. I'm gonna cheat here, guys, because I honestly forget how to do it, but I'm just gonna use auto, right? I'm gonna say auto temp node is equal to this head. This could, I think this is supposed to be like node t, and then this is supposed to be a pointer. If this doesn't work, guys, I'll use auto. Okay, but yeah, let's go ahead and do this. While temp node dot next doesn't equal null. Here we can say cout temp node data, and then we can end line here, end L. Okay, did I use the namespace std? Yeah, we have to do that. So using namespace std, awesome. So now we're using the std namespace. Lastly, this actually is not going to get the last element in the list, since the last element's next is going to be null, so this is not going to run. So we're just going to have to do this again after the while loop, and then we're golden. Let's go ahead and try this out. So the way I want to make it is doing an array. So let's go ahead and make an array. Okay, so we'll make an array using the array std array library from the standard library C++ provides you. And here we can say string. Okay, and we can say my test is equal to, and then here we can say I a linked list. That's 5. Okay, that's 5. We can also make it work with something else like an integer, and we'll just try this out afterwards. Okay, now we're gonna loop through this array and add it to the list. Okay, first we need to make a list object, so we're gonna say DSA link list my list, and then I think that should be good. Oh, we gotta specify the templates. So specify a template. We're gonna be working with string here, so that should be good now. And then we're gonna say for string I my test, and we're gonna say my list dot add to list, and we can just put I in there, and then don't forget your semicolon, and then there we go. We're adding to the list every single time the loop goes through these values. It adds to the list. Now let's print the list. So we're gonna say my list dot print list, and let's go ahead and try running this. And you know, it might not run in the first time. You know, I'm doing this solely off the top of my head. I forgot my semicolon. Simple mistakes. Oh, it worked. Oh my god. Okay, well that's a problem. It seems like the print is the problem. Let's make this auto. Yeah, because I knew that was like gonna not work. I don't know why. Oh, whoops. And then we can run the, oh, it's not, wow, oh, it's because we haven't updated. So let's go back to here, guys. So here we have to make temp node iterate through the linked list, so it's working. It's just we have to do temp node is equal to temp node next. Okay, now with that bit of code, that should be a nightmare over. I am a linked list. Awesome, guys. So that is how you implement a linked list. Thank you guys. Actually, you know, since my my students might be watching this, let's go ahead and figure out how we can put this on a header file. So anybody who is just looking for the logic of a linked list, you can go ahead and, you know, get your code. I'll put it in a GitHub repository, and I'll put it in the description so you guys can see how to do it. For my students, I recommend you guys watching this part. Let's go ahead and make a header file. So you can just say linked list.hvp. Okay, now this linked list HVP, this is called a header file. Now this is how you get your code to be modularized. Modularized means that your code lives within another file and you can import it into your main file. So the way header files work is they're kind of like a normal C++ file, just there's a little bit of rules you have to follow. So you can still include what you want to, like IO stream, definitely going to include that. But what header files need is declarations and implementations. Okay, so declaration part, all you gotta do is just copy all this code. Alright, let's just copy, put it in here, and now the declarations, I'm going to show you exactly what I mean by declarations. So here we're declaring a namespace, that's fine. Here we're declaring a class, that's fine. Here we're declaring what's it called, properties, I have it right here. Here we're declaring constructors, but we're actually having some logic here. I think actually constructors are fine, but we're gonna have to get rid of these. We're gonna have to get rid of those curly brackets, because those curly brackets means that you're trying to put logic inside of them. So get rid of those. Here it's totally fine. We're declaring a function, but notice how we have implementation. This is called implementation. Usually they're within curly brackets, so just get rid of the curly brackets. Same here, just get rid of the curly brackets. Okay, and there we go. That is your declarations. Same thing goes with the linked list. So let's get rid of these curly brackets. And let's get rid of all this. I know it's pretty scary removing all the logic. Okay, there we go. Now we have the implementations that we have to do. So the implementations, pretty much you pick the classes that you want to have the implementations done. So for this, let's go ahead and say DSA node, and we're gonna say I think we still put the void here. I forget. I think that's good. And then we're gonna say get okay, DSA node T, and then we're gonna have to put the template as well. So template type name T. So that's good. And now we're gonna say get so look at the functions, right? So we have get data, set data. For this one it's set data, so we'll say set data. Okay, and here we're gonna refer to DSA is not a function. Oh, okay, we're gonna have to add one more global. I'm sorry guys, I'm so sleepy. I'm starting to fall apart. This is called the scope of operator. What's it called? Colons? I don't know. These are called the scope of. So we're gonna have to go ahead and specify which function we're gonna use, and set data is the one we're gonna use. Set data is gonna take the T data, and then we're gonna say this that data is equal to data. Okay, so that's how you implement this. Okay, so I know it's kind of a lot of hard work, but you know it pays off, because then your code is much more cleaner. So now we want to do get data, and then this is going to return T, and then this is going to return this data. Okay, so it's like you're rewriting your whole class. Alright, that should be good. Not sure why. Template type name. Oh, it's because this is supposed to be no parameters. Alright, let's go ahead and do the same with set next and get next. So you can just go ahead and copy this. Okay, and then we're gonna say set next, and then set next is gonna take a node. It's gonna be T, and then this is gonna be next. This dot next is equal to next. This should be a pointer. And then there we go. It just has to match your declaration, guys. It's not that hard, you know. Okay, so this is gonna be node T and return this dot next. Now, I think that's all for the nodes. It's still giving me an error here. Get next. Let's see how it looks like. Oh. Huh. That's not supposed to be like that. It's supposed to be like this. Whether I messed that up in the in the main video, then that's kind of yikes, but that's how it's supposed to be. Now this shouldn't be giving me an error anymore. Node is not a template. Oh, I have to do DSA node. There we go. Alright guys, so that's how you do the implementation for the node. Finally, we have two more things to do, and that's add to list and then print list, and then we're done. So let's go ahead and say template type name T. We're going to say DSA link list this time, and we're going to give it a T. And then what are we doing here? We're doing add to list. All of them are void, so put void in the front. And then here we're going to say add to list. And then this accepts T data, I believe. T data. And then all you gotta go do is go back to your main.cpp and copy the logic. So if we just copy this, we can go back here, and then that should work 100%. Let's go ahead and do this for the other one. Template type name T, and then we're going to say void DSA link list. Something's up here. Something's up here. Did I forget to put a semicolon somewhere? Oh no, that's good. Gotta give the template parameters, and then finally we can say print list. And then here we're gonna go ahead and copy the logic one more time, and then we're good. Alright, so that's good. Now, instead of having all this mess here, we can simply just go here and say include what's it called, linked lists. Okay, so now we include linked lists, and yeah, that's how we do it. Now this should still work, believe it or not. We just got rid of all of that, and if we save this, oh wait, we still get some errors here. So up here we have to use the namespace std. Right, we save that, and then line 67, we forgot our semicolon. Looks like, yeah, okay, line 67. Alright, okay, 55, we forgot our semicolon. Okay, I guess we have to have these guys. So make sure to put your curly brackets. I guess that was my fault, my bad guys. And there we go. So now if I run main.exe, it still works like a charm. So that's how you modularize your code. Alright guys, thank you all for watching, and I'm out.